Alright, if you turn to the very back side of that practice sheet right here, we're going to start off the lesson with some exact trig ratios. We use trigonometry on any triangle that's not 45, 45, 90, or 30, 60, 90 because those kind of right triangles we can find exact values because we have some rules to figure out missing side lengths. But what will happen though, right here you see this picture, this is a 45, 45, 90 right triangle. If this is 90 and that's isosceles, then both these angles have to be 45 degrees. What we're going to do is we're going to find out the exact trig ratio. Like if it says sine of 45, obviously we can go to our calculator here. If I bring mine up real quick, computer's being slow, and type in the sine of 45, and it'll give us an answer, but it's some dirty decimal. It's 0.707, which is approximate, you know. What we're doing today is finding the exact trig ratios. So to figure out what the sine of 45, the cosine of 45, and the tangent of 45 is, first I'll write down my best friend here when it comes to trigonometry. That's SOHCAHTOA. And let's make up some values for the side lengths in a 45, 45 right triangle. You can make up any numbers you really want to as long as they're true. Like I could make this be 11 or 15 or 90 if I really want to. But the easiest number to deal with besides 0 is 1. So let's make this leg right here 1. So then this other leg would have to be 1, hence the isosceles-ness. And if you know the leg of a 45, 45, 90, you can find the hypotenuse by multiplying by square root of 2. So that's 1 square root of 2, or we'll just write that as the square root of 2. So I made up side lengths that are true, and now let's figure out what the sine of 45 degrees is. First, let's focus our attention on a 45-degree angle, and honestly, it doesn't matter which one. It could be this angle right here or that angle up there. It doesn't matter, but just pick one of them, and let's focus all our attention and follow the rules for SOHCAHTOA. Sine is supposed to be opposite over hypotenuse. Well, if we're focusing on this 45-degree angle, opposite side is the 1, and the hypotenuse is the square root of 2, so the sine of 45 is 1 over the square root of 2, which that is an exact answer. It's not a good answer because it's got a radical in the denominator, so let's get rid of it by multiplying by radical 2 over radical 2, and we'll get a final answer of square root of 2 over 2. That is the exact sine of 45 degrees. And if I punch that in, square root of 2, second square root of 2, come on calculator, close the parentheses and divide it by 2, I should get that same decimal as before, and I do. So we just figured out exactly what the sine of 45 degrees was. It was the square root of 2 over 2. So let's do that with the cosine of 45 degrees. The cosine of 45, if I go green here, cosine is defined to be adjacent over hypotenuse, so the adjacent side to that 45 that we're picking on is 1, and that'd be over the hypotenuse, which is the square root of 2, which we just figured out is the same thing as the square root of 2 over 2. I just simplified this right here, so why do it twice? The cosine of 45 degrees is also the square root of 2 over 2. Let's see what the tangent of 45 degrees is. If I go red, the tangent of 45 is opposite over adjacent, so opposite the 45 is 1, and adjacent to it is 1, so 1 over 1, which is actually just 1. So those are the exact trig ratios, and the way to figure it out is to always sketch yourself a triangle that has this angle. And if it's a 45, 45, 90, if they want the exact sine of 45, remember you got to have a right triangle, so sketch a 45, 45, 90. The other special numbers we're going to deal with are 30 degrees or 60 degrees because we have two special right triangles, 30, 60, 90 right triangle and 45, 45, 90. So to figure this out, we want to sketch a picture of a 30, 60, 90, which is already provided for you on the back of your paper, but when you're doing your homework or something, you sketch your own picture and make up some numbers. The short leg's the key, so what do you say we call that 1? If you know the short leg, then the hypotenuse will be twice as much, and the long leg will be the square root of 3 times the short leg. So there's my side lengths in there. Now let's do a little SOHCAHTOA. And let's do the sine of 30. That means you want to focus all your attention around the 30, and sine is opposite over hypotenuse, so 1 over 2. And I don't want to see any of this 0.5 stuff right here. I want 1/2 for an answer. Cosine, adjacent over hypotenuse, so square root of 3 over 2. And the tangent of 30 is opposite over adjacent, so 1 over the square root of 3, which is not good enough, so we'll get rid of it because there's a radical in the denominator. And there is the exact tangent of 30 degrees. Why don't you pause the video and see if you can do that now for all of these 60 degrees. So you can use the same picture, but you just got to realize what opposite, adjacent, and hypotenuse are. So this is 1, this is the square root of 3, and this is 2. And now you're focusing all your attention around to 60 degrees. So try it out. Pause. Okay, so sine is opposite over hypotenuse, which is the square root of 3 over 2. Cosine is adjacent over hypotenuse, so 1/2. And tangent is opposite over adjacent, so square root of 3 over 1, or just the square root of 3. So when they ask you for the sine of either any one of the trig functions of the numbers 45 degrees, 30 degrees, or 60 degrees, those are special numbers. Sketch a picture and find the exact answer, not the approximate answer, just by punching it in your calculator. Okay, so now let's go back to the front of the worksheet where we see a problem like this, and today we've got story problems, and we need trigonometry to help us out. So it says when the sun is 32 degrees up from the horizon, doesn't that sound like horizontal? The horizon, basically, a fancy way of saying we're talking about like the ground or some sort of horizontal. The wall of a store casts a shadow 25 meters long. How high is the wall? Well, first thing is there's some small assumptions being made in these problems. Assumptions of like the ground being flat and buildings and all that stuff, but you always need a right triangle to get stuff going here, so we assume that that's 90 degrees right there. And let's just put this information in the picture. Believe it or not, you actually can measure what angle the sun's at. You know, the sun's at a different point at all minutes of the day and everything, and you can use a clinometer to figure out exactly at what certain time the angle of the sun is. So that's not totally unbelievable right there, that sun at this point of the day is 32 degrees above the horizon. But it says the store casts a shadow 25 meters long. And what you're going to do today is this worksheet's going to seem pretty darn easy because all the pictures are drawn for you. On your homework, the pictures will not be drawn. You have to draw your own pictures. So realize, first, let's not screw up where a shadow is. Our shadow's located on the ground. So 25 meters goes right here. They ask how high is the wall. That would be this. So they gave me this angle. We're focusing all of our attention around it. This is opposite that. This is adjacent to it. So the trig function that deals with opposite and adjacent is tangent right here. So I will do the tangent of the angle measure equals opposite over adjacent, and I will take 25 times the tangent of 32 in my calculator real quick here and realize what x is approximately, and punching that in, I got x to be about 15.6 meters. We do need a label since it's a story problem. I hope you're punching stuff in. I don't want to go back and forth between the calculator, but please punch stuff in to see that you're getting the right answer. So there we go. That thing is about 15.6 meters. So when the picture's drawn, it's actually pretty darn easy. Second example, from eye level, 5 feet off the ground. So let's see if we can put that in the picture. From eye level, 5 feet off the ground. Here's a person's eyes, and they're saying 5 feet off the ground, so 5 feet. 20 feet away from a flagpole, so 20 feet away from the flagpole right here. Wouldn't that be 20 feet? This person's 20 feet away from the flagpole. A person has to look up at an angle to see the top of the pole. Let's pause for a second and realize, normally, is it not true that a person looks straight ahead? You know, that's what their neck and head normally do. Okay? So, normal line of sight, we always have to have some sort of horizontal. I'm looking straight ahead, looking straight ahead, looking straight ahead. If a person's got to look up 40 degrees, something's got to move. Be it their head is going to tilt back 40 degrees, or their eyes are actually going to roll up 40 degrees. But when they say they're going to look up, that's called an angle of elevation. That means they're just looking up 40 degrees from their normal line of sight. So the 40 degrees actually goes right there. They want to know how high is the pole. Well, what we need is a right triangle, and hopefully you see we have this green right triangle right here. What we assume is that's 90 degrees, and if we put an X right there, if we figure this out, that'll be a good helper for us to solve this problem. So I got a 40-degree angle right here. That's opposite, that's adjacent it, so tangent is my function. Angle measure always goes next to the trig function, and opposite over adjacent. I will take 20 times the tangent of 40 by punching that in my calculator real quick, and I will get X is about 16.8. But that's still not good enough, because all that is that's how much X is. I want to know how tall the flagpole is. Well, isn't this right here a part of the flagpole? And that's 5 feet, so I just got to add 5 to this and realize that the flagpole is about 21.8 feet was our label. That's how tall the flagpole is. All good? Let's try another one. From the top of a building, you look down at an object on the ground. So here we are standing at the top of the building. There's some object down here on the ground. It says your eyes are 55 feet above the ground, so I have that in the picture for us already. And the angle of sight called the angle of depression. In the previous problem, we just did an angle of elevation because we looked up. Angle of depression means we're going to look down. So once again, do you realize that we have our normal line of sight right here, which is horizontal, right? This is our normal line of sight, but it said if I got to look down 50 degrees, that means from my normal line of sight, I'm going to roll my eyes or move my head 50 degrees down. So 50 degrees actually goes right there, which that's kind of weird because that 50 degrees is not inside this triangle that we're going to use at all. So what we need is we have to do a little bit of assuming. There's a couple things you could do, but it all bases around the fact that we assume that our normal line of sight and the ground were parallel to each other. And since we assume these are parallel, we can get alternate interior angles congruent. If that's 50 degrees, then this angle right here is going to be 50 degrees. They want to know how far is the object from you. Here's the object. Here's you. This right here is not how far the object is from you. That's how far the object is from the building. What you want to find is this. How far is the object from you? So we will call that X. We know this. This is opposite. We want to find this, which is the hypotenuse. So according to SOHCAHTOA, opposite and hypotenuse means we want to use the sine function. Angle measure goes there every time, and opposite over hypotenuse. So you can't have an X downstairs, so let's get rid of it. And you'll have those go away. X times the sine of 50 will equal 55. And now I'll get rid of the times sine of 50 by dividing. X equals 55 over the sine of 50. And now it's time to punch that in. And X is about 71.8 feet. All good in the neighborhood so far? Sweet. How tall is this building? So right here. All the info's there. You go ahead, pause the video, and try. So let's check real quick. Opposite and adjacent are what we're dealing with. So the tangent of 40 will equal X over 800, opposite over adjacent, and punch that in. X is about 671.3 feet. What I'd like to do is kind of talk about real quick how this answer makes a lot of sense. And it's all based on, if this is a right triangle, imagine for a second if this angle was 45 degrees. Okay? If this was 45 degrees and this was 800, would it not be true that this would have to be 800 feet also, because this right triangle, if that was 45 degrees, would be isosceles then? So a little trick that I'm kind of showing people to see if they do things right is the closer this number right here is to 45, the closer these two side lengths are to being the same to each other. And 40 degrees is actually pretty close to 45, so since this is close, 40 degrees is close to 45, that means that this answer right here should be close to 800 feet, which it is. And isn't it true that if this is 40 and this is 90, this has got to be 50 degrees? So shouldn't the bigger side be across from the 50 and the smaller side be across from the 40? So it's got to be a little bit less than 800. So the closer that number is to 45, the closer these two guys will to be being the same. Now imagine real quick that this wasn't 40 degrees. It was really, really, really small. Say it was like 1 degree. Now wouldn't it be true that that thing would be very, 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 very small, and this distance right here wouldn't be much at all? So the smaller the number, the smaller the side length across from it, which we kind of learned in the 30, 60, 90. That's why the smallest side is across from the smallest angle. Alright, so just things to kind of look out for. Other page, from the point at the foot of a hill, foot, is it not true if you're standing up that your feet are down here at the bottom? So the foot of a hill means the bottom of a hill. The angle of elevation, so that means the angle going up from the horizontal. We're always basing it on a horizontal. And here our horizontal, is the ground. That was a very poor picture, but the horizontal is the ground. So the angle of elevation is 15 degrees, so that's from the ground up, right? Up. From horizontal up, elevation. The distance from the foot of the hill to the top of the hill, here's the top of the hill, is 150 meters. So from the foot of the hill to the top of the hill, so we'll put that in there. Let's try to spell out top real quick there. 150 meters. Find the height of the hill. Remember, height is a fancy schmancy word for altitude, and altitude always has to be perpendicular, so they want me to find this. Base your attention around this angle, use trigonometry. So please pause and figure this one out. This is opposite, this is hypotenuse, so that's a sine function. The sine of 15 is going to equal x over 150. And I'll take 150 times the sine of 15, and x is about 38 point something. 150 times the sine of 15, 38.8. Sorry, my answer key was all smeared out. So about 38.8, and the label was meters. Think again. This is small. All right, 15 degrees is a small angle, so 38.8's got to be smaller than 150. 150 is the hypotenuse, and it should be a lot smaller than it, honestly, because 15 degrees is a small angle. So x is about 38.8 meters. This is a great problem. I really get upset when people put information in the wrong place. A 30-foot ladder, a 30-foot ladder, a 30-foot ladder. I've got the picture drawn for you. Please put the 30 in the right place. A 30-foot ladder. It's a 30-foot ladder. It's a 30-foot ladder, meaning the ladder right here is 30 feet. A ladder leans against the building, making a 72-degree angle with the ground. The ladder makes a 72-degree angle with the ground. Please put the 72 in the right place. The ladder makes a 72-degree angle with the ground. Believe it or not, as easy as it seems to put stuff in the right place, when you do not have the picture, it's a lot harder than you think. Find the height of the building. So that's this, and then find the distance from the base to the ladder to the building. So two different problems. Let's find the height of the building. Let's call that h for height. I don't care what you call it, but I call it h for height. So this is opposite. That is the hypotenuse. So sine of 72 will equal opposite over hypotenuse. So I'll take 30 times the sine of 72 and figure out that my height is about 28.5 feet, and that's good because it's a number that's less than 30, because 30 is the hypotenuse, so that's good so far. And 72 degrees is a very big number. You know, the maximum it could be is 90, right? So this should be very close to 30, because the bigger the number is, the closer it should be to the hypotenuse, even though it shouldn't be bigger. So that's very good. The other thing they wanted us to find was the distance from the base of the ladder to the building, so that's right here. I'll just call that x since I used h for the other variable. Just as long as you have different variables, it's all good. So still focusing around the 72. This x is adjacent it, and that's the hypotenuse, so that's cosine of 72 will equal adjacent over hypotenuse. And you punch in 30 times the cosine of 72, and I'll get x being about 9.3 feet. And you notice that's a pretty small number. Well, that's because this angle right here is 18 degrees, right? This is 90, that's 72, that's 18. The smaller the angle, the smaller this side. So things starting to make sense a little bit here, hopefully. Last one, we get to draw our own picture. So this is very much like your homework. So it says a plane takes off at a 24-degree angle with the ground. Use a straight edge, please, to draw these pictures. We got a geometer, so I'll get my cool straight tools out here. And the first thing we're going to do is draw the ground. Ground. Nice and flat. A plane is going to take off at a 24-degree angle with the ground, so I'll try to make it look pretty decent, about 24 degrees. You know, nothing accurate, but there's a plane taking off at 24 degrees. And what does help is to put some rough sketches in here. There's a plane up here. So I'll do my best to draw a cool airplane. Yeah, plane. Even if you can't draw, the best thing to do is at least just put the word plane right there. There's a plane up here. So a plane takes off at a 24-degree angle with the ground. How far has the plane traveled in a horizontal distance after traveling 3 miles? That's weird because it says how far has the plane traveled after it's traveled 3 miles, but it has something else in there. It says how far has the plane traveled in a horizontal distance. So horizontal means basically going left and right. After the plane's traveled 3 miles, well, once a plane's taken off, is it not true that it travels in the air? So the plane itself has traveled 3 miles from the ground to right now. They just want to know, like, how far has that been horizontally? Well, of course we need a right triangle, so we'll drop our altitude in right here. And they want to know x, the horizontal distance, like how far has it actually went. So basing around this is adjacent it, that is the hypotenuse, so that's a cosine situation. Cosine of 24 will equal adjacent over hypotenuse, so a little punch of the calculator, and 3 times the cosine of 24 is about 2.7 miles. So that's good. Less than 3. Good answer. That's only one part of the question. There's another part here. Let's go, I don't care what color, blue. How high, this is the part that everybody boogers up. How high in feet is the plane from the ground after it has traveled 3 miles? So same picture, but how high is the plane basically? Let's go green. They're wanting us to know this distance, the height, I'll call that h, but the thing is they say in feet. So you got two choices of what you could do. You could figure out h right now using this picture, but that answer, hopefully you realize, would be in miles. Or you could change this hypotenuse's distance to actually miles right now by taking 3 times how many feet are in a mile, and you should have that memorized. There are 5,280 feet in a mile, so we'll take 3 times 5,280 and realize that that is 15,840 feet. This distance right here, it was 3 miles. All I did was just change it into feet real quick. Now if I want to find h in feet, I'll use this big boy right here, and then I'll be good to go. So opposite is h, and that's the hypotenuse, so the sine of 24 will equal opposite over hypotenuse. And boom, 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 punch in. Take 15,840 times the sine of 24, and I got about 640 42.7 feet. Alright, so not bad, having to draw our own pictures. What I want to do is I want to do one on the homework with you, but before we do that, let me go to the homework. And it's this. See this first problem here? It's all about finding the exact trig ratios of this, this, and this, because you have all the answers to this. We did them on the practice sheet, and it's very easy to copy them down, copy them down, copy them down, but that doesn't do you any good. What you should do is sketch yourself a rough picture of a 45, 45, 90 to help you for these, and a 30, 60, 90 to help you for those. Make up the lengths and see if you can figure them out on your own without copying it. Then check from the answers that you have to see if they're correct. So, I did that. Now here on the first page, I want to do number 4 with you also. All these trig story problems, but here it is. Let's go through it together. It says an advertising blimp hovers over a stadium at an altitude of 125 meters. Let's stop and let's draw a picture. So we got a blimp out there in a stadium. First, let's start with the ground. Come on, brother. And I'm going to start with things on the ground. We got a blimp that's hovering over a stadium. So that means the stadium's on the ground. So check out this sweetness right here. Yeah. And then I'll write the word stadium in there. And people are going nuts in there. Yeah. Stadium. There's a blimp that is hovering over it. Do. Blimp. Look at that awesome drawing. And that blimp is hovering over a stadium at an altitude of 125 meters. So that means from meow to meow, from the distance the blimp is from the ground, 125 meters. Good deal? Let's keep reading. The pilot sights a tennis court at an 8-degree angle of depression. So one thing to realize about the old blimp is here's where the pilot sits. La 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 la. The pilot, isn't it true that normally the pilot will be looking straight ahead? So we need to sketch this in. But what happens is this pilot is looking down because they say an angle of depression, and when that pilot looks down, he or she sees a tennis court. So, tennis. Right? If you don't have pictures, as long as you have the words tennis, stadium, blimp, that'll all be good. But the question is, where does the 8 go? If the pilot looked down from their normal line of sight. Here's the normal line of sight. To look down 8 degrees, the 8 actually goes right there. And that's the part that gets messed up all the time. Angle of depression from the horizontal. We assume that the line of sight and the ground are parallel, so really, inside our right triangle here, the 8 degrees goes right there. Then they say, find the ground distance in a straight line between the stadium and the tennis court. So that's this. I'll let you use trigonometry, and the rounding. And an answer saying about 100 meters. So please round how they tell you to round. You know, if you got an answer of 11,235.7 and they say round it to the nearest 100, that would mean that since this number right here is less than 5, you'd round that to 11,200 meters or whatever, feet, whatever it was. So make sure you're rounding correctly. Okay, so there's some story problems. There's another one on the homework. Oh, it's on the second page here, just to give you a heads up. It's number 7 about Martha and Heidi. What that means is you need 2 different pictures, one for Martha, one for Heidi. Okay, so right triangles are the key. Martha and Heidi, Martha and Heidi. And be careful if there's any of them that have 30 degrees, 60 degrees, or 90 degrees. I want exact answers, not approximate. So be careful of 30, 60, 90s. And please come on in if you have any questions. Thanks. Have a good one.